Hello, hello. I think we are live. I think I am live. I don't think there is a V in this, but yes, I think I'm live. So I think that makes a lot of sense. One sec, let me drop same thing on Discord. Yeah, and not to forget the link. Yep. That's it. Yeah, we are live, and I am back. I missed the stream yesterday. Got a bit stuck with something. Unfortunately, my mic is still on mono, I believe, and I'm trying to figure out if I can somehow switch this to um, like stereo or something. Audio input capture. Yeah, if I actually make this mono, it will be easier for you. Yeah, that makes sense. So now it's not a problem. You will feel this as a little better option. I think that should be better now for anybody in the chat. Uh, and I think that should be enough. We'll have a quick recap of what we did. Also, I just pushed everything on the last stream to GitHub. We'll just simply create a README for this later on. But what we did was, is there a commit history on that? I don't think there is just one commit. Yep. Okay. So we basically wrapped up our whole ingestion server, log ingestion server, and now what we are planning is to stress test this. Wait, GoLang? No? How is that possible? Yeah, okay, it's better than it. And I also fixed my music player today. So we have that as well. Let me see if the volumes are good. Yeah, I think that should give you a good number. Uh, just let me know if it's too loud. Okay? Whoever joins the stream, let me know if it's too loud. I think I should also share the stream on other platforms. I'm not sure what that. How many other platforms do we have? Oh, great. So it's fine. Hello, welcome, Virus. Welcome to the stream. We are having fun. I'll give you a recap in like a few minutes. Let me just see if the volume is fine for everybody. Just should not overpower my voice. Should be good enough. Anybody else? Whoever is on the stream, uh, is the music too loud? Like, do you hear music over my voice? Yeah, I'll get to it. Just let me set up the whole thing for us. Okay, so when I'm not speaking, you'll have something to hear. It won't be as silent as I feel here. Okay, and for me as well, it will be a little easy. Yeah, okay. Flip and Fox, welcome. Welcome to the stream. Welcome back. Um, and okay, so now time for the recap. Do you guys want this? Do you want this thing to be here, or like can I throw this somewhere? I don't think you need it, right? The song credits, like okay, credits to the artists. It's up here. Okay, so if you like certain song, you could just have the name here. I'll just play Nefx. Yeah, that should be good enough. Okay. So what we are doing today, in the last two streams, if you've not watched the last two streams, go after this stream and watch them. We basically built a Go-based logs ingestion server. Okay, so a log aggregator, if you understand that part. And in simple terms, it's basically a server that will keep pulling logs from other services. Okay, so it's not service dependent. You can deploy this as an individual service and keep pushing logs to it from Python app, from Node app, from whatever. Okay, in JSON format, and it will take those logs and push it into a CouchDB server. Okay, from that I do remember that I need to start my CouchDB server. So, and that is not yet nice, because I just uh, reverted back from one of my time shift instances. The new Hyperland update basically killed my whole system. So I had to go back in time and revert to an earlier instance. So we don't have a CouchDB instance here, and I don't even feel like, yeah, it is okay. Okay, so we do have it. Okay, the image is not there locally, so it will pull one, and we don't have any problems with that. Okay, because no seeding and all. We'll just start pumping logs to this, and what we'll be doing today on this stream is basically stress testing this thing. So I need to see how big or how much load this thing can take. Okay, without any optimizations, uh, we basically like threw in some code and started just getting things done. So while this is happening, let's drop it on the side and let's look at the code. Okay, let's have a simple recap. So we have an ingestion server struct, which basically is like a class in other languages. But Go does not have the concept of classes. It has concept of structs, embedded structs, and functional structs. So this is basically a pure function which will create a new ingestion server. So you could call this function from anywhere, so it doesn't matter. But these functions which have like a small prefix like this, these are like instance methods. So just to show you, we have like the new ingestion server, okay, which takes the configuration and the database instance and give me new server, and I can call these methods on this server. But prepare itself is not a method. See, it's just text. So this prepare is an instance of this server, okay, and that is defined like this. So you create a function and you say, okay, it's part of this ingestion server. Simple, okay. And then you could use this variable, this declaration here, to reference whatever you want from the struct. So the struct fields, these can be referenced in these methods. Okay, struct methods. Simple as that. Then we basically built, okay, I think our CouchDB is now running with the ports exposed. Yes, 5984 is the only port that we need to expose right now to get connected with this. And let's see if we can get a running instance from this. We have makefile, which will run. Yep. So it runs, it can clean, it can build, it can clean and build, it can do all those things. Okay. And what I want is to run something else. We have a client.go here that I can run to generate some logs. Okay, which will be added to one of these ingestion endpoints. We'll get this ingesting log on this terminal. Okay, and we'll get sending log or something similar to that. I don't remember exactly what we did. Yeah, we get a sending log on this terminal here. So this is our sending, this is our receiving, and this is our uh, file explorer. I don't think we need that. We'll keep it anyway. Let's go to the Go CouchDB log aggregator, and let's do go run bin client. Yeah, so it did send a few logs and left, and we have this. So we got a few logs. Okay, and to see what values these logs have, what I'll do is I'll make another HTTP request to this server. Okay, the same server. Curl. I don't remember exactly. Let's see, localhost 5 or 6 4 8 8 was the endpoint, I think. 6588. Okay, so it was 6588. slash logs. Is it logs? Okay, I don't need that. I just need this. Yes, none need that. Why? What happened to this? Okay, whatever. So we need. I need to see where I can view the logs because yeah, so it is logs. That's it. And to make this a little good on the eyes, we can pipe it to JQ. Okay, let's take this on fifth and make this clear. So these are the logs that were sent from the application. Okay, and it's all fresh because we just instantiated the whole DB instance. So these are the documents that we have. The IDs are auto-generated like we have in other NoSQL databases, MongoDB, for example. This ID is auto-generated by CouchDB. CouchDB also has the concept of revisions. Okay, so the same document with exact same data will fall under the same revision. So that's one thing. Because if you see, even the time is exactly same. So these two documents are exactly same. So they have the same revision. The revision values are same. You update the document, the revision changes. So if you want to track something, CouchDB gives you that ability by tracking revision. Okay, so you could keep tracking the revisions, and you'll see that okay, the last revision for this document was something else, and current is something else. So something changed, and based on the two revisions, because CouchDB also tracks the document itself, the change. So you could just fetch the two revisions and see what changed. You definitely, I think, have to do something around that. Okay, so what we'll be building today is uh, this whole testing rig for us. We'll be using K6 to test this thing and see how far it can go. And I think having a test setup here itself would make sense. Test K6 and maybe like mock.js because K6 uses JavaScript to test. But before that, let's explore what K6 is. K6 load testing. It comes from Grafana, so it's a Grafana project, but it's open source and it's also free. You don't have to do anything. The open source version. So this is how you write a very basic API and test. Okay, the data you could make anything out of it. The response could be anything. You can check for certain things like a success login is R200. These things will be printed and also tracked, and you have sleep. And what I want to say is, if I create a scenario with 100,000 logs, each generating a random log, okay, how far can my server go? Uh, Also, just to be sure that my terminal is not blocking or NeoVim is not blocking, we'll run the whole thing on a separate terminal instance. Okay, so it will have its own terminal instance, nothing interfering with it. So it won't run inside something else. What I want is the binary. So we click on open source and download, and it will give me, I don't want this. What I want is the binary that I'll get probably from the Docker. Grafana K6 get redirect path K6. Will it give me the form again? Nah, self-managed. Yes. K6 download. No, 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 doc. No, download K6 binary. Yes. GitHub releases. And the deprecated stats T, I don't care. K6 experimental tracing has been removed. Okay, URL grouping support in the browser. Top level await is now supported, and complete RSS support in web crypto. Okay, that's good. That's good. Might help us in testing. So in experimental FS, we're saying to use await, but now you can simply await top level. So basically, they implemented a top level await on this. Okay, so what I want is K6 Linux AMD 64 dot tar AMD 64 tar GB. Yes. What is clean link? Is there a concept of clean link? What the F is a clean link? Okay, let's just open this here. Duplicate everything down. Great. So I had two people. Now I have one person. I want to know who left. So basically, who is watching? Somebody is watching. No, I do have two people. Is it two people or one people? I don't know. Still down. Okay. Flippin' Fox is here. So Var is left, I believe. Okay, no issues. So if you find anything interesting, let me know. If you find anything troubling, let me know. Also, I will be making use of certain commands that you might not know. So if I do something that you don't know, you let me know again. Uh, okay, so now that I have the K6 binary, it extracted the K6 binary. This is just a folder creation. So it extracted the K6 binary into this folder. So I want to move the K6 binary into the K6 folder. So instead of removing, let's move the K6 dash something something K6 binary into test K6. Yeah. And now I can basically RF K6 dash and all that thing. And also remove the K6 star binary. So now I don't need all that stuff. Uh, let's write a K6 simple K6 test. So from K6 slash HTTP, is that something that I need to use? With check export default function, and I think I'll be doing a few other things. One sec. Can I change the low latency mode? Like, can I reduce the latency a little more? One sec. Give me a sec. Let me see if I can reduce the latency a little. Okay, okay, okay. I don't think it gives me the option right here. No, I don't have the option to change the latency mode now. So it will be a little slower for me. Yeah, timestamps make sense. And yeah, okay. So this is a little for me. Okay. But okay, let's continue. Let's see. So we have so we are writing a scenario where I need to smoke test this thing. Okay. So just for a heads up, we'll understand what a smoke test is. Okay. So smoke test is basically check if the application responds, uh, check the most basic operation on the application. So for us, this will be the smoke. For us, the smoke test will be basically hitting the health endpoint a few times and then hitting the logs endpoint once. Okay, so I think we just need to write HTTP. Yes. Or is there a check? I don't think there is a check. So this is not the thing. HTTP dot get on the URL. So it will be HTTP localhost 6588 slash help. And based on the response, because it's JS, we could write simple JS here. Okay, you could also write your own functions. We'll be doing that when we'll be generating our own log data. Okay, because I don't want to have keep pushing the same document. We'll randomize the documents a little bit. So CouchDB also has problem with revision. Okay. नहीं तो वो same revision चिपकाता रहेगा बार बार, and it will be easier for CouchDB. You won't get same documents again and again on a live application. So from a live application. So right now we'll be testing this using K6 and random logs. Then what we'll be doing is we'll be starting up or basically putting together a very small Python app that will generate JSON logs, and we'll send those logs here on our application. And I think we'll also change the database for that test. So that also makes a little bit of sense. Okay. So I want this to be test. Okay. So now we have a test database that we can connect to. It will create the database if it does not exist. If you don't know how that happens, uh, go back to the last stream after this stream. Okay. And you'll get to know because we implemented a lot of things there and we had a lot of talk there. Response dot status is what I want. Exactly the number. So assert. Do I want assert? No, I don't want assert. I want check. Check comes from somewhere. I need to know from where. So not this. I need to write a very simple test. Not this. Getting started. Yeah, writing my first test. Just give me something that tells me where. Okay, check also comes from K6, I believe, directly using K6 HTTP requests. And I could have checks. Where is checks? Checks. Yeah, check also comes from K6. Okay, great. So check comes from K6. So I'll import check from K6. And check check the response for this value and run this and set it against this value. So I'll check the whole response and I'll check status 200, which is an object with r and r dot status equals 200. And I also need a third equal to just to ensure that my types are correct. Okay, so this the difference here is if I do this, then 200 is basically equal to 200. So this is valid, okay, but this is not valid. So this is type coalescing, okay, what JavaScript calls it type coalescing. Basically, if I can compare them somehow, I'm happy. So it can convert this 200 into a string and then compare it, okay, which is easier. And then this is becomes basically valid. But here type coalescing does not work. Uh, we actually tell JavaScript that match the type and then the value. So then this does not work. Okay, so this won't be valid. But this this will be valid. Okay, so this is valid, but this is not valid. Not this. Yeah, this is not valid, and this one is valid. Okay, so this can work across types, usually in numbers and strings, and this never works across types. This is very type strict. So I want type strict. I don't want to match numbers. If I'm wrong, I'm wrong. I need to know that. Okay, so or we could just say success. That also works, and that's it. We can also export a set of options which will have like let me see what options. Yeah, scenarios. Show me scenarios. Yes, so we could export options where we can create scenarios, name them, give them an executor, certain views, certain start time, stop time, some environments if we want. Okay, so you could do a lot of things with scenarios. But I think the best thing we will be doing is by setting the views, by setting up virtual users. So I don't want any of these. What I want is Yeah, options. How to use options. Let's see. Let's see how to use options. So I want this. What I want is I don't want to have multiple scenarios under one. I'll create one file for each scenario, but we'll have stages and we can set up thresholds. We don't need to reuse the connection, no point. Okay, we'll basically not do that. So we could actually test the loop. We'll also have one where we will reuse connections. So we'll see if whichever one performs better. These are the hosts where we'll be testing. So that makes sense. K6 no connection reuse. We could do a lot of that by with environment variables too. But exporting in a set of options, I think, is much better. Yeah, we could also set up a JSON and then pass it via config, which basically is the same thing. Okay. If you don't want this, then let's set up stages. And what I want is a duration on 10 seconds and views is 10, and then have multiple. So every 10 seconds, or yeah, for if we'll start with 10 seconds, go up for 5 seconds, and then come back in 10 seconds. So in the next 5 seconds, I'll make it like 20, then 30. Yeah. So this will create a graph. We'll start with 10 for 10 seconds, and then in the next 5 seconds, we'll pump to 20, and then next 5 seconds, we'll pump to 20, and then over next 10 seconds, we'll come down to 10. And then it will gradually come down to 0. So that is it. Anything else that we could use? I don't think we could use anything else. Okay. Okay, it's called target again. Not to mess up. नहीं तो बाद दिक्कत होगी. So we use की जगह it's called target. That's it. I think that's it. We are happy with that. And abhi let's run the whole thing. It is running. And now I can run the K6. So let's go into test K6 and we run this via K6 run smoke dot slash K. Wait, what is does K6 has permissions? Yeah, it does have permissions. Take care. Run smoke. So we are running the whole test. Okay, and we are basically hitting the endpoint here, but you're not getting anything because there are no logs. ठीक है, health वाले endpoint पे there are no logs because I don't think we ever added those logs. Yep, see there on the health endpoint there's only a log when something errors. So we are doing something on the health endpoint. This will help us set a baseline कि एक empty endpoint which does nothing उस पे हमें कितना टाइम लगता है and what do we do with it. Okay, तो ये है हमारा result. So our average request processing time is this. Okay, this duration. We are taking 600 microseconds to process one request on average, and 90% of our requests are being processed under 1 ms and 95 under 2 ms. So that is the latency where nothing is happening. So you could call this as idle latency. ठीक है, जहाँ कुछ भी नहीं हो रहा है वहाँ पे it takes about 2 milliseconds to respond without any operation. Now let's run a similar test on the logs endpoint. Okay, so smoke is done. Now I need a stress test. So stress.js, and I think we'll copy a lot of things from here. Okay, and let's go to ingest JSON. This is where we'll be pushing the logs, post, and what is it? JSON or body? What is it called? क्या करता है? What is the documentation for post? Second parameter is body, which is JSON body. So I could just call it JSON log body, something like that. And JSON log body will come from create new log, which will create a new log entry for me, and we will have that here. This function create new log. Return a few things. I want random, so let's see कि K6 का random कहाँ है, whether K6 has random or not. सर्च कर लेगा random. Does K6 have random? Random seed है, random beacon है. No, 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 no. I just want something from K6. Yes, K6 Grafana doc random seed. So random seed comes from K6, and I can random seed with mat doc. Okay, so this is how we'll do random. And we need, yeah, and we need random seed from K6. So random seed comes from K6. Okay, and now map dot random will give me something. I think we could use date dot now to seed it. तो वो हमेशा एक अलग वो रखेगा. So we'll have a different value every time. And date dot now will also have a different value almost every time. And it's in milliseconds. I want in microseconds. Uh, new. Uh, how was it? Perf new performance perf now dot now. So what is perf now? I don't remember what is perf now. DOM higher as timestamp है ये. Measure, I don't want to measure, I just want microseconds. ठीक है, so we don't need this. Let's go with date dot now. I don't think इससे ज़्यादा हमें चाहिए होगा. We need random, so we'll have a level which will be something. We'll have a message which will be something. We'll also have a timestamp which will be something. And what else do you have in log? You could have a trace or something, but I think this should be enough. ये जितना बड़ा होगा ये उतना ज़्यादा scale करेगा, right? So it will impact your time उसी के according. We'll test that too. Let's have levels and messages. So the level will be error, warning, debug, log, info, and critical. That's it. And messages, messages, I'll just keep this. I'll just say like this. Uh, log entry under like level level. That's it. And we'll use level. And levels, so const level will be levels dot add, or no, it does not have add. So index कर लेते हैं. And I want two things. The first random is uh, timestamp, which is I think good enough. Timestamp or timestamp would be date dot now as is. ठीक है? So we'll also get to see कि ये चल रहा है नहीं चल रहा. And I need index. So const idx is math random into levels dot length. So that will give me a number between 0 and whatever number of entries इसमें होंगी. And I'll always have an IDF between that. Now we need to run this. So we create a new log, we push the new log, and we see if we get 201. Okay, so because our success is always 201. हमने जो अपना endpoint लिखा था, that always returns HTTP status created, which is 201. Nice. This test database, okay, and 201. Let's stop this, start again. Should always write some good logs on running. And yeah, and also I think we can, because we are stress testing, let's check कि ये कितना झेल सकता है. So for the first 10 seconds, we'll have, let's say 250 requests. Then in the next 15 seconds, we'll triple this, so it becomes 750. or let's pump this. So in the first 10 seconds you'll have 500, then we'll have uh like 5 10 20x. Let's 20x this, so that's 10,000. In the next 15 or let's say 20 seconds this goes even higher, so let's 20x this, so that will become 200,000. So from 500 to 10,000 to 200,000. Okay, and then we'll also have a graceful tear down. So in the next 10 seconds, it will come back to 10,000 and then to 500 and then it will drop. And now let's see. So here, this is a graph that you will see. I think I just need to see कि एक environment variable होता है that I can set to open the browser. और there is a web viewer in this. इसमें एक वेब व्यूअर है जो आई वांट टू ओपन अप. Is it K6 Studio? No, it's not K6 Studio. It's something else. K6 result output. Yes. I want the HTML output. Yeah, web dashboard. Okay, K6 web dashboard equal to true. I can do this. Or I think there is an option. Yeah, okay. Okay, so I think this should be K6 web dashboard period. I don't need that. Export is this. So I need both. And now what we'll have is yeah, and then we'll have K6 stress, and let's for safer side restart this. Okay, it says K6 नहीं मिला because obviously को पता ही नहीं K6 क्या है. Okay, run. नहीं भूल जाता तू. Stop this. ठीक है, यहाँ नहीं run करते because this is very small terminal. Yes, and we'll run the same command here, but inside test K6. So now I can make this bigger, and we also have the dashboard that I can open. So open it here. Something happened. The dashboard killed. Okay, so let's just wait for the stress to run. Okay, it is initializing. It's not sending. Yeah, it is getting killed because I think I'm doing a lot of stress यहाँ पे. So let me put this somewhere. Yep, there's also frame drop because it's having that problem of uh, too many requests. So to test it here, ठीक है, क्योंकि मेरे system पे काफी चीजें चल रही हैं. Let's test it up to 20K. Let's or maybe 25K. You could run this on your okay. Stream health is a little effed up. Okay, but the stream is sending data, so you might experience a little problem here, but ठीक है, it'll be back. It'll be back on track. Okay, let's start with 25K and let's see कि हमारे log ingestion कैसा चल रहा है. From there, we'll proceed with something else because 25K तक it could go बहुत आराम से. Also, if you can hear me and there is no buffering or the stream is lagging, let me know in the chat because I don't see anything that might be that laggy. I'm not having any more frame drops, and even this is working fine. So if there are still any problems, let me know in the chat. I'm looking at the chat. So we are getting logs. You see, we are ingesting a lot of logs. Great. No, that was a different problem, but yes, no more frame drops, and we are just testing. But every test requires resources, and for some overexcitement, I basically pushed it to the limit. Success rate is something we have 100% failure rate for some reason. Did everything fail? I don't know. Did everything fail? That is what I want to know. So we were able to handle 875 requests. Okay, maximum was 24,000. Nothing happy there. Waiting time was 420 ms. So now the latency has jumped a lot. Okay, we were processing in microseconds, and now our 95 percentile is basically 1.5 seconds. So you could say that the worst time that we took was 6 seconds, but on average, every request will take about 1 second. So this basically died. Okay, it basically died. Success was 0%. Everything failed. All requests failed. We sent about 759,000 requests and everything failed. So now we need to see what's happening. Okay. Now, so now this is optimization. Now what I'm trying to do is I'm trying to see why all the requests failed. Also trying to get some insights into what could be the bottleneck. There could be a like a queue or something, or maybe this write is failing, or something is happening. I don't know. So we need to figure out what's happening and we need to fix this so that we are able to at least handle some percentage of this test. Not everything fails. So I'm still considering failures, but not 100% failure. Also, I think we need to write a request logger here. So most probably we'll be writing that. So let's first write a request logger. Maybe not like that. Maybe like this. Uh, how are we going to write that? As we serve HTTP. Yes, this could be a func. Okay, I cannot assign that. No, it's not failing from the K6 side because I am getting the request here. I don't know, but K6 does nothing. It just sends the request and logs whatever comes back. So K6 is not doing anything with the request. It's just like any other log client. You're sending the request and you're getting something back. So what I want to know is why did all of my requests fail when my smoke test was successful? So let's try to run the smoke test again. Let's see if that works. So we are sending some requests, no interrupted iteration, so we did not do anything. We are on 8 and we'll be maxing out on 30. This already tells you a rough estimate. So we are running one scenario, 30 views max. It will take about a minute of maximum duration, including shutdown. So the running time is 20 seconds, and yeah, it will take some time to run. See, now it's ramping down, see, from 10 to 0. And now we had success. So it's not that that is failing. It's basically that endpoint that is failing. Because in this request, we sent the requests over to Let's see. In the stress test, we are basically hitting this endpoint. HTTP 6588 ingest log. Okay, where we actually push logs with a post request. Do I need to await this? I don't know. Did I miss an await? Like, don't tell me I missed an await on HTTP things. HTTP requests. I don't think I missed an await. There was checks, right? Checks. No, I did not miss an await. So this does not require an await. It automatically is blocking. Okay, so body size, whatever, it checks. And so there's nothing that this does. We're basically logging what we're doing. So there's nothing wrong here. So the smoke test is successful. So we are basically able to send the request here and the server is responding. And it's also having some very good time responding. So 15 nanosecond request connecting time, which is like super fast nanosecond. You have 12 microseconds of sending time, receiving time. There's no failure. So request failed here is 0% and request failed here is 100%. So this whole test failed and we need to see why it failed. So we'll write a smaller test to check this, fix this, and then stress it again. Okay, so that's how we'll fix this. We'll comment out this stages and we'll write a new stages. A duration of like 5 seconds and a target of 5. And then in the next 5 seconds, we'll go to 10. And then in the next 5 seconds, we'll go to 20. And then we'll go back to 10. And then we'll go back to 5. So 5, 10, 15, 20, 25. So about 30 seconds. Okay. Considering like some additional time here and there. We'll do a stress test again. But this is not exactly a stress test. I'm just using the same file to test it again. I don't want to write a new file for every new test, but that is exactly what you want to do. You don't want to clutter a single file all the time. You basically want to have separate tests, each test with its own configuration, each test with its own requirement, its own test cases. But yeah, that's the whole point of all this thing. Okay, so we have again failed requests. So something is wrong, okay, with concurrency. What I could tell you is something is wrong with concurrency because the 95 percentile is still millisecond. It's still 1 millisecond, but all of our requests failed. So let's see why our requests are failing by making a manual call. Okay, so I'll make a call request by myself. Um, we look, or let's use the client. We already have a client, right? So let's use the client. We don't need this for. Okay. Yes, and yes, client.go and sync groups. I think we'll just define a count of 20 and wait for count. And the count is not 20. I'll just send one. Oh no, go run bin client. Yeah, and also I want to add. So okay, so we did not get this log, so the status was 201. Where? Where the number of instances? I don't get you. Because this is basically like these many requests almost in parallel. So we're sending these many requests almost in parallel, multiple requests in parallel, but it's simulated by a certain number of users, virtual users. That is what views are called. So we basically were able to run 6 virtual users sending these many requests. So this request is spread across 6 users. that is not the problem. The problem is the request is failing on small test as well. So there is something wrong with the endpoint itself. It did not fail on our client because our client is sending logs sequentially, one by one. But once it starts getting logs like this, it starts failing. So there's something to do with concurrency, either on the CouchDB side or on our implementation side, something to do with multiple requests being sent at once. That is what I can figure out so far. Because see, we did send one single log, okay, and it went through and we did not get this error. Now if I said 10 logs, it'll it still sent it. So these are 10 logs in parallel, right? So because it's a Go routine, it's almost in parallel. What if I send 100 logs in parallel? Will it fail? Will it start failing? It did not fail. So there's something else wrong. Either in the payload or something else. I don't know. It might be in the payload. So time, message, level, request ID. Could be anything. Time, message, level, request ID. What if we check the test create new log? So it gives me a new log that I send as post body. Um, Params are not required. Object form encoded. What is that? Okay, so I think I need to set the headers here because it expects because I am sending application JSON, but what it expects is form encoded. So another thing to know. Let's see if this works because again we are still on the smaller test. We're not on the bigger test. We're on still running on 20 views. I don't know if it will work or not, but this might be one of the problems. Also, share the stream with more friends. Bring in more people. We'll have some fun. We'll talk. Mhm, mhm. Join the Discord if you still haven't. Cores won't be an issue. I don't think cores would be an issue because this is again a server to server request. It's not involving any browser. Cores might be an issue. It is possible, but here it's it's not a problem because everything is running out of a browser context. So that is not a problem. Cores is a very specific problem with browsers. If you're not inside a browser context, there's a very less chance you'll face cores as a problem. So did it run? Did we have? No, it still failed. We still have 100% failing requests. And I'm not getting any error logs. So I'm still ingesting a lot of logs, but I'm not getting any error logs. So it's something to do with something else. Let's improve our ingestion. Let's first improve our ingestion and see what's happening. It will write 500 and fail, or it will write 201 and fail. And let's add another log for printf, and we'll just say info uh, or not error failed to add entry and percent s with err dot error and a new line, obviously. And here we'll add info log entry with level percentage added new, and this will be from the body. So body level level. Yeah. It's so cold. I'm not able to type. Shit. Okay. Now let's see. अब अगर हमें log आएगा, so we'll be able to or actively visualize it. Let's restart the whole thing. Let's restart the whole scenario. Let's start with the client first. See क्या होता है. So we added a set of log entries with warning, warning, warning. Yeah. It's about now. I don't know what's the time right now. What's the weather right now? Let me see. Okay, so it's 8 degrees here where I am. 8 degrees Celsius, whatever that is in Fahrenheit. And now let's run the stress test because that is what was failing. Is it initiating or is it sending? It's sending. But I'm not getting any logs. Why am I not getting any logs? Something else is failing. It is sending the request. Yeah, it is sending, but I am not getting any success or failure logs. My time is not moving. So something else is actually wrong. So now we know that this test, whatever it is doing, ingest JSON. Am I hitting the wrong endpoint or what? Let's see if the test is actually doing what it needs to do. It should do. Ingest JSON. 6588 is the endpoint, right? If I'm not doing any weirdness. 6588, yep, it is the endpoint. On localhost, yes, HTTP localhost. Ingest slash JSON post request with JSON body and application JSON as header. It's content type. So what is it? What is it? Am I not getting the JSON? Let's see if we can decode this on the K6 thing. I'll just give it a very static thing. I'll write, or is it that? Could be that JSON stringify if it expects something. Now it's 8 here. It's 8 degrees and I'm actually chilling. So it is cold. We want level, which will be let's for now just say error. We have a message which will be failed to write content, and we'll have a timestamp which will be date.now. So what is my LSP doing? What LSP is loaded? Go PLS is loaded. For some reason, Tailwind CSS is loaded here. Why? I don't know. JS maybe. And we also have what else is loaded? TSLS is loaded. Tailwind server. Whatever. Okay. So let's see if this fixes anything. I don't know. Also, let's just make this JSON log body, so I can change it as required. JSON log body. Okay, I think that should be good enough. And okay, this was the stress test, right? So let's see if it is a K6 problem. Yep, it was a K6 problem. Yep. Now I'm getting logs and it is adding log entries. So we'll also have a very small test run with this because now that we are able to run with 20 views, I think it will be much easier for us to run with the larger set. Yep, the success is all good. It was a problem. It basically wanted JSON stringified thing with application header. So that's one thing. Our request time for 65 percentile, I'll just ping this, make this bigger. Request time for 65 percentile is 61 ms. So in 61 milliseconds, we are basically processing 95% of our requests. 223 is the maximum. I think it hits somewhere there. And now we can restart the whole server. Okay, basically change the config to use a different database. So we start fresh. Okay, let's call this stress test. Okay. Yeah, it does. It does. It does run even without headers, but supplying the header ensures that if it wanted, it will have it. So that's one thing. Also, I'm writing a test, so it's better for me to specify the header and expect it to be there. Okay, and now let's get back to the actual thing that we wanted to test, right? Okay, now I can also check this. Let's see if our JSON body thing was working. I don't know. I never checked this. I don't need that. So we did not check that. And let's see. Post request to dash dial TCP connection. Okay, okay, wait. Connection refused because I'm not running the server. If you guys are free sometime, join the Discord. We might have some watch party on YouTube or something because coding is not the only thing I want to do. So I've restructured my Discord a little bit for you to find it very handy. You can jump in and we'll have fun. Okay, 33.11 milliseconds is what we got. I think that's a good score considering we are only sending like 11,000 requests. So out of 11,000 requests, our request rate is 400 requests per second. That is what we are doing. So this is the value, and this is the value that you usually want to optimize. This value is your iteration time or request per second. If you say, it's also called throughput. Okay, so technically you call it throughput or your traffic rate. Okay, but HTTP request per second also makes sense. This is very close to 450 on 20 users. Okay, we did 6 on average with 19 maximum. And now what we're going to do is run the big test. Okay, we're going to run the big daddy and uh, keep the small daddy outside. Yep. So big daddy coming with 25,000 requests. I don't know, you might have some frame drops. If you still have some frame drops, let me know in the chat as soon as the frame drops. Okay. I don't know. This might go very horribly wrong. Nothing will happen. It's just a number that you can later on optimize. So okay, it basically died. Okay, so it's basically a measure of how many requests in 1 second you can handle. That is basically what I'm testing. So I basically get a rough estimate of what my server on by itself, okay, on single instance is capable of. So if I have that number, okay, in mind, and I know that my server can handle, let's say, 1,000 requests per second, then I can manage my traffic according to that. So if I'm having an influx of like 6,000 requests every second, I know my server can't handle more than 1,000. So I need five more instances because I know that my number is 1,000. If I don't know how many requests my server can handle, I don't know when I need to scale. So you'll get to that problem when it comes your face like a bull. Okay, so it's coming to you with its horns straight to you, and now you're like, I don't know how many requests my server can take. I don't know why it's failing. It's failing because it could only take 1,000 requests which you never tested. That is what we are trying to do, right? We're trying to figure out the limit of our server instance by itself, running a single database instance and a single node, right? So now if I need to deploy this somewhere, this time, yeah. So now if I want to deploy this somewhere, and I also want to tell the other person who's going to use that 1,000 is the limit here. So they would have an upfront idea of 1,000 requests per second is this thing can take. If I have more traffic than that, I'll need to scale this instance or slow down my traffic or divert my traffic, whatever. But you basically have a rough idea before your traffic comes in. Okay, so we are testing that. And the other thing that you're basically going to optimize is, okay, I'll show you when this stress completes. We don't need the dashboard, we only need the HTML report. Not good. Or do we? Just let it be. Okay. It died. Because it's not running. 200,000, I think, was a very big number. It was a vaguely big number. So it wasn't the best idea to run 200,000 requests on a laptop. Doesn't make a lot of sense. It is doing well. I think the server is doing actually well. It is doing well. No, it failed. It died. Started dying. See, it started dying. Right? It started failing. That is what I want to figure out. When does my server fail? Okay, so I don't get surprised. Uh, that completely depends on the deployment you're using. So if you're on EC2, it's basically a shared deployment. But yes, it's a dedicated instance. Here, what I'm doing is I'm trying to figure out when my request fails. See, EOF, right? End of file. It starts failing. It can't write as much. So I need to figure out what my uh, limit is with this instance. See, 10,000 interrupted iterations because it's timing out. Now it's yeah, it does. It usually does, but I've tested applications that do way better. So we're still at the same rate. So now see, we did 20 users with the same rate. Okay, 450 approximately, and we did 20,000 with the same rate. So now you have a rough estimate of the rate of requests that your server can handle. At least on my infrastructure, it can handle 450 requests per second. So if I'm getting the traffic of 450 requests per second, I'm happy. And above that, this will have a hard time coping with that request. And the request time now pumps to 23 seconds with 54 seconds because I'm having like 25% failure rate. So what I can figure out from this is whatever I did, 75% of my requests were good. My median time is 900 milliseconds. Okay, so the center time, it's basically maths. My central time between minimum and maximum is this. Minimum was 8 milliseconds. The earliest requests, which were run on the free server, took 8 milliseconds. Maximum was when it started dying. So this was basically because of the time. A request duration was like 1 minute. basically full 1 minute. So 95% of my request will complete in 1 minute. That's very long. That's shit long. Okay, we don't usually do that. We hit 24,563 requests when we were running, and we planned for 25,000. So our max was basically 25,000, and when we were zero, our max was 9,000. So these numbers usually don't have that much problem. I'll show you something else. 74% is our success rate. Okay, so 74% of my traffic was successfully pushed. I failed to add 25% of my request. Now I can drop my number to 75%. Okay, 10,000 out of 43. So now I know that I can drop it to 75% of this number. So let's try to drop it to 75% of 25,000, which is like what, one third? 8,000? 8, 4, no, 6,000. Yeah, they usually take like 5 minutes. So that makes sense. Okay, so we'll try to push this out, and we'll try only with 10,000. Let's see. Let's see if we can process 10,000 requests. Okay, so we'll have a rough estimate. Let's see if we can handle 10,000 requests. Also, I think there is an HTML report here somewhere. Yes, HTML report. I'll show you this. Okay, I'll show you what HTML report is. This is, I think, much better than looking at the console. You'll see. It is adding all entries. I don't see any problems. It's doing. Yeah. I see some problems. Yeah, it's failing. I see some problem, but it's failing on 10,000. So on my infrastructure, on a single node of CouchDB, I am having uh, a limit of 10,000 requests in parallel. That's what I'm having. So this is a very rough stress test and load test, okay, for you. If you're building something, this is a very simple thing you can do. Okay, it does not take time, and it basically tells you how good your application is, or where your application is in the terms of scaling. Now, started failing, and it died. So 94% is my completion rate. So I can still drop this to like 8,000 and be happy, right? So out of 30,000, like 30,000 succeeded, about 1,700 failed, 5% failure rate. Okay, so if I get 10,000 requests, there is a 95% chance I'll push everything. So, or in other words, in 10,000 requests, you'll basically handle 95% of the traffic. 38 seconds is P95 because it died. So what you can do is you start looking at things to optimize, because on this traffic load, you're having a 59-second time because of the timeout. So once you start dealing with the timeout, you start handling things in different ways. Your average time is 8 seconds. Okay, we're still on the same 400 requests per second rate. So now I can guarantee you that this single node instance with single application running can handle 400 requests per second. You can make this into a cluster. Okay, which means you'll not have one instance, you'll have like 4 or 5 instances connected to the same database, and they'll be handling traffic. So you basically 4 times your traffic rate. Yeah, it's like a DDoS attack. So basically what we're doing is a DDoS attack, but that helps me understand when my server dies, what is my limit. So an actual DDoS is like a million requests, like every second, every 5 seconds. It's something like that. But we are doing it on a very small scale. We are only sending like 10,000 requests to this server. But yeah, it's like a DOS attack. It's a denial of service attack. So I'm trying to figure out when my service is denied. So 95% of whatever this number is. So just about 9,000 requests per second is when my server is at its peak. And yep, I wanted to show you the HTML report, which I'll open in Firefox. Yeah, and bring it here. So this is the report. This is the HTML report. It's graphical, so you can see the green line is the requests per second. Okay, the blue line is request duration, and any failed request will be here. It's basically like an upward graph. That's it. Nothing more. Request per second is 340, 340. It actually went to 618, but the average was down to, like, because it was handling less traffic here and more traffic here. The average was somewhere here, 400, 450, somewhere down here. Yeah, definitely. But what I wanted to show in this, like, this is basically the last stream for the Couch and GoLang log aggregator. That side project is basically done. Now what we'll be doing, if we plan on doing more streams on that, is we'll be extending the functionality. So we won't be sticking with the same thing. We'll be adding, like, accepting YAML logs, accepting JSON L logs, or exporting logs, maybe writing a front end around this to make this like a standalone project where you can search things, write queries, uh, calculate stuff like that. But I have ideas for other things, like uh, another teaser, because you guys are here. So the next stream I'm planning is basically building a protocol, a chat protocol. So just like you have HTTP, gRPC, or other protocols, we'll be building our own chat protocol where we'll be basically allowing live chats. So we'll have an open connection, uh, open bidirectional connection with reading and writing, and you'll be basically building around that. So that's what I'm trying to do. Let's see if we are able to do that. That will also be a very good uh, side hustle that we can do. You'll also understand what a protocol means, because mostly when you talk about protocols, everybody's like, what is a protocol? Protocol is basically a set of definition of how things work. So if somebody says it's like, yeah, I'm not sure if it's secret or not, but yeah, our own network with our own protocol built over the default TCP. So the transport layer is same. We're using the same TCP transport, the same almost similar HTTP layer, but we are building our own protocol on top of the TCP. So we are basically reading raw data, parsing it into our own structure, and then using that. And the same on the other side. So that will be like our own server, our own client, because I don't think anybody else would be able to parse that data uh, in like a browser or something. Browsers can't parse our protocol. So we'll be building our own server, our own client. Usually that's what happens on game servers, because every game is different, and you don't know what the game requires. So they usually build their own protocol mechanisms. If not a full-fledged protocol, they basically build their own protocol structures where they define, like, this message means that message means that, and that code means that. So they don't have to send everything across. They basically send a code, and the client understands that, okay, this is what I need to do. Yeah, I have that one in mind, which I thought might be interesting. Yeah, definitely, exactly. They need to know my encoding. They need to know how my packet is structured. They also need to know whether I use a packet and what my packet delimiter is, where my packet starts, where my packet ends. A lot of stuff. They basically need to know my protocol specification to write a parser that will understand my protocol. And that is exactly what we'll be doing. We'll be writing a protocol specification for us, not a professional one, a simple protocol spec. And based on that, we'll be building it maybe in GoLang or something. Yep. But there are not a lot of people that will enjoy this, because I don't know, React is happy or something. I'm fed up with React tutorials, so I thought of building something different. Because everybody tells you how to build a backend server. Let's write protocol. Let's do something different. This is the same metric that you see there. No, it's a different metric. I think this is a different report that we are looking at. How many views does this handle? Views, views. So it's eight views. Okay, so this request is one from the K6 20 version. Stream response API. Yeah, it's basically yeah, okay. You could basically subscribe and hit the bell so you don't have to wait. Whenever I schedule a stream, you'll get a notification and then you can click on the notify me button. So when I start streaming, you'll get to know. That is how YouTube works, I think. I'm not that fed up. I'm just fed up with tutorials. Uh, there are a lot of tutorials that will teach you the same basic four projects. Build a dashboard, build some kind of crypto like app or landing page or something, build a chat application, or build any random shit that comes to their mind, like any small thing or something. Game dev requires experience. Game dev always requires experience in low level stuff because you need to optimize for resources. When you're building a game, it's important for you to optimize for resources. How much memory is being used? Is there a spike? What is the maximum memory being used? What is the minimum required memory that I want? Like in terms of RAM, free RAM. What GPU optimizations I could make to just run the game faster in the same set of resources. So scalability comes very late in the game. Scalability is like when you're actually having a player base. What I'm talking about is when you're not having a player base. When you're just starting to push the game out and there are 10 people using. You can't have everybody on the same 8 gigahertz, 8 gigabyte GPU, right? Everybody can't have an 8 GB graphics. So you need to optimize your game to run in whatever resources are available, minimum resources. Like if you're building FC 24 or FIFA or something, which actually requires like 2 gigabytes of graphic, that makes sense. But that is after you've done your optimization and you know that, okay, I can't optimize any further. Mhm. Mhm. Okay, anything else? Yeah, just make sure that you don't pre-optimize. You don't need to optimize unless you measure. Always measure before you optimize because you don't know how much and what is needed. So if I did not run this test, I would be sitting and optimizing a lot of things here. Okay, I could sit and optimize my decoder. Like I could write a faster decoder. We could figure out a faster way of decoding. We could basically skip this because this is not my code. And that's it. So the only thing that this has is a decode and a write. If it is slow, it's either because of one of these or maybe both. Okay, but unless I measure, I don't know. I'm basically in a Heisenberg uncertainty zone. If I start focusing on this, this might start to bottleneck me. If I start focusing on this, this might be the reason that I'm actually in bottleneck. So I need to measure. How do you measure? You basically add some console logs and see which one is slow. That's how you measure. Or you do other things. There are a lot of other things. Yep, I think this basically sums up a lot of our testing mechanism. Okay, we are basically ingesting JSON logs, or we could handle about 9,000 requests per, like 9,000 requests at max in parallel with 450 something requests per second. And CouchDB is good enough, I think, if you're early in the game or you're not having a very heavy traffic influx. CouchDB is, I think, a single instance something. CouchDB. It's single node something I forgot. Multi-master sync that scales from big data to mobile. Yeah. HTTP JSON API designed for reliability. Okay, so this is designed for reliability. It won't kill your data. So that is one thing. You can rely on the fact that this will be available almost all the time. And it uses couch replication protocol. We are basically running a single node, but see, single node database. Okay, any other database behind application, and then you could run it in a cluster. Okay, so cluster is basically having multiple databases with in CouchDB they basically have multiple masters. So uh, there, if you set it up like 3 masters, 3 slaves, or 3 masters, 3 replicas, one master for one replica for each master. So you basically have 3 different instances to write data to, and still have the data in the same place. So like if you did not get it, what is that thing called? Whiteboard. Yeah, it's web whiteboard. So I'll basically write a very small start a whiteboard. Miro. This is basically Miro. Okay. Yeah. So let's try to make something out of this. So I want. Let it be, I don't know. So what I want to tell you is, what I'm trying to tell you is, there is one master, second master, third master. Okay, and each of these have their own slaves, just a different shape. Okay, so slaves basically provide read. So, and these are all running in a cluster. Okay, so now uh, let's just do 1, 2, and 3, and this could be like anything. These are their related slaves. Okay, it uses couch replication, so whatever comes here goes here and then goes to other, and then goes to other. So basically it replicates by itself, whatever their couch replication mechanism is. Okay, but it basically is, whenever you write it to one node, it will tell everybody else that there is a new data available. Okay, that is one. That is what replication is. You basically replicate the data to every other node. And what happens is, if there is a lot of traffic, these, you basically write to the cluster. You tell the cluster I want to write. Okay, and the cluster will tell you write on this, then write on this, then write on this, then write on this, write on this. So cluster will basically divide how how the writes happen. But the fact that I can make 400, let's say, requests per second. Okay, that means my one node can write 400 requests per second. That is what it is sending. So I am sending 400 requests from here, and I have another same node that also has the same limit, 400 per second. This is sending another request. So basically, when the cluster starts receiving data, it is receiving 800 per second, 400 from each. Okay, and then it starts writing. So now you don't know which master you're writing to, but what you know is, if one of these has a limit of, let's say, 9,000, okay, 9,000 requests, like in parallel. So now you have 3 of those. So now your total limit is 27,000 managed by the cluster. So you, and having a cluster is like, if you want to scale, you just add another master and slave, or you just add another slave. If you're getting more reads than you're getting writes, then you add another slave. If you're having more writes, like more data is being pushed in but not reading as much, you just add another master. So it starts writing. So now you have another node with a limit of 9,000. Okay, that is a very small, uh, very basic way of understanding scaling. You don't need to scale unless you need to. Simple. Or you don't scale unless you need to. It's as simple as that. It's not difficult. It's just required or not. I think that's it. We'll push everything, whatever we have. Yeah, not specifically not the K6 binary. So I don't think we need the K6 binary on the, so RM HTML report and RM with the K6 binary. And we'll just add everything that we did into to our repo. Repeat, add tests and test, load test everything. Yep. And now I'm pushing everything, and now everything is available to you on GitHub. If you want, the link I think is already in the video description. If it is not, I'll add it. Yeah, it's already in the stream description. So if you want to check this out, you can check this out. Clone it, fork it, try it by yourself, add more information, augment it with more shit, check whatever you want to do. Okay, that's one way of doing it. If you want to build it with me, you could do it on stream. Okay, with me, tell me what to write, ask me what to do, ask me if something is good or not. And the other way is, if you want to do it by yourself, this is the repository. You clone it or fork it, and you start playing with it. Okay, you add another function, you write more code, you write another handler for yourself. Like, what if I want YAML logs transformed into JSON, and then you write an YAML ingestion endpoint that will transform data into from YAML to JSON, or from YAML to like a GoLang map, and then that map is pushed into CouchDB, because again CouchDB uses GoLang map. So it's that simple. You just try it out, because unless you try it out, you won't get to know what's good or what's not. I think that's good enough. We're already too long into this ordeal, and how long? Yeah, 1.5 hours. It's still half an hour short from the last stream, but yeah, last stream we had fun. We were talking, we were playing. There are not a lot of people to talk today. Uh, so if Flippant Fox has anything to ask me, I am open for discussion. I am open for questions. But for sure, the chat is a little slow, so you'll definitely need. Yeah, just it's just you. It's just you and me, and if anybody else comes in, then. So if you want to ask something, you are open. It's just you and me. But remember, whatever you ask, it will be on the stream. I'm not basically ending the stream. We are still on the stream. So if you want to ask something, I'm still here. We could explore something if you want, if you tried. To jump to a directory. Z, this one. Because I could jump without going full. So the actual path is this, but I just wrote this. I could go here, and the actual path is this, but I just add this. So that's Zeox type. This, it's basically like a CD replacement. So when you do CD dot dot, uh, so let's say I want to go into this YT folder. Okay, if I do CD, it won't remember my folder. CD never remembers your folder. Okay, but if I do Z will remember my folder. So if I hit YT, I could go to all YTs there. And if I do ZI YT, then it becomes interactive. So if there are multiple matches, I can select between one of them. So if I want to look for Go hyphen, I don't remember the project, so I can just go like this. This also has Mongo Dynamite, right? So Go hyphen, right? So, and I can choose between which one I want to go. Yeah, you definitely need this. I am on Arch. Am I still on Arch? Yes, I am on Arch. Yes. So for me, it's very simple. For me, it's just backpan install. Okay, you could also do that. If you're on Arch, you could do that. Backman S uh, Z Oxide. I don't think this is available for Windows. So if you're on Windows, I don't know. Check it out. If you're on Linux, it is definitely available. So I just basically updated it, or basically did nothing. I just reinstalled the whole thing. So that's it. System is up for an hour 39 minutes, and session. This is basically session time. It's not system time. It's session time. And hour 38 minutes is what the stream is. Amazing. The Arch family. So we basically just Pacman S this. Pacman sync it, and you'll get it Z oxide, and the Z command is by default available. So you don't have to set it up. You just start using Z instead of CD, and it will start remembering everything. I don't have to do a lot on that. Nothing else. What else? Anything else that you need to ask, that you wish to ask? I have a lot of these. I just play like this. Let's. I also need to check my Discord. Great. Somebody is in voice. Okay, so that's a different server. My server is empty. There are very few people here. Yeah, mostly offline. I'll just hop in sometime and like in one of these lobbies, play a game or something. You joined. When did you join? Did not get a notification of you join. Just messages. Yes. Mhm. Is there a welcome channel? I don't see. There is no welcome channel. Okay, so you basically joined and I gave you a role. This is you, right? So yeah, I gave you a role and now you're open to discussion. If you have any problems, use any of these channels. I get notified whenever something happens on this Discord. So if you have any problems, like any time of the day, you could drop in a message, and I or anybody who's available will be open for answers. Yeah, backend died. Great. So I don't think we have anything else. I think next stream will be after a bit because I need to plan out the protocol. I need to see how I'll be taking all that stuff. Is it expired? I don't get a different link when I try to generate one. This is the exact link that I get when I try to generate a new Discord. If I invite people, edit and set it to never expire and there is no limit and generate a new link. Okay, I think so your copy button is not working. If I click on that and nope, I think I'll have to do this again. Or maybe disable that and then try to invite people. Yep, it's set to never and no limit and generate a new link. Now it generated a new link. Okay, I'll update it in the description. Yep, happy. Yep, done. So now we are done and the Discord link would be working. Yep. So I think that's all we have for today. We'll be back soon in some time. I don't know. Probably. Okay, so it's I think what date is it today? 16. Yeah, let's plan for 18 or 19. So I'll take a break tomorrow, plan out a few things, and probably on 18 and 19, I'll schedule a stream and we'll start building the protocol. We'll have fun. We'll build our own chat protocol and explore more. Uh, Now that just you are here, nobody else is here, but I think people would be watching this stream in future, maybe like 2 years from now. So for everybody watching the stream in future, share the channel, okay, and bring more people. That's what I want. I want more people because I don't want to code alone. That is the reason I wanted to stream. I do not have enough time to edit videos and I love to stream. I basically love to code like live. So bring in more people. We'll have fun. We'll enjoy because I need more people to point out my mistakes. No problems. I can plan around that. The only thing is, whenever I plan a stream, I basically post out a new video, not video, a community post on channel, and the comment box there helps a lot. So if there are exams, people can drop in a message that there are exams. They'll be ending that whatever day, and we'll plan according to that. Because all I want is more people to come hang around live and have fun with everybody. So me coding alone only makes me better, but me coding with everybody else will make me better along with everybody else. So let's let's basically build the thing together. Also, I think the idea of building a custom protocol is a good one. So I'll probably be like asking more people to join in if they're available. Let's see. Let's see. I basically need some sort of promotion here. Okay. Okay. Uh, we'll meet on the next stream. Thanks for joining in, everyone. Flippant Fox, shout out. Okay, and enjoy your time. I'll be back on the day, whenever the stream is scheduled. Have a good night and chill out. It's very cold here. Okay, bye.